Hello, I'll be giving you a walkthrough of our alignment demo. Start moving myself over here. So, what are we looking at right now? Simple. On the left hand side we have a transcript. On the right hand side we have some sort of structured data. It's important that the transcript in itself will be organized in a way such that it consists of separate parts. Here the transcript have been split into sentences by stops, and the structured data has been split into sentences as well. What the alignment demo does is that it takes one sentence here and then it tries to map it to the corresponding transcript. So as an example, here the structured data are some criteria. It could be that they mention duration of pain. Here we indicate that we've spotted it 2 places in 7 and 8 respectively. This is where we found pain. But the alignment demo is much more powerful than what we're just showing here. We can also create our own inputs here. From here, I'll be showing you a couple of examples. Let me just grab a transcript here. And we can grab some facts. These are facts that we have generated. When I run it through now, through the alignment endpoint, I get some results. Here we have all the facts, and on the left-hand side, we have the transcripts themselves. If I'd like to see where the facts come from, I can simply mouse over them, and I can see the corresponding indices in the transcripts. Here it's 4 and 6 respectively. I can do the same thing for all my facts. What's important to note here is that if we produce a fact that we cannot link back, something is probably off, right? Because if there's nothing that can align us to the fact that should come from the transcript, a mistake has probably occurred. Another example for this could be shown where I grab a transcript. I also grab a SOAP note that we've generated. And again, I can do the same thing. I can align them and I can see all the points in the SOAP node that were generated from the facts, wherein they correspond to from the original transcript. This is a relatively powerful tool because it means that we now have a way of explaining where the model gets its sort of triggers from. So here it says persistent headaches, dizziness, nausea, fatigue with no clear triggers. We can see in 4 they've said yes, I've had persistent headaches, dizziness, and so on. And in 8 they say not really, it seems to come and go without any obvious reason. So there, the physician will have an easy way to quickly get an overview over where important information lies in an otherwise impossible to comb through text. Reading through all these 31 lines would take significant amount of time. This also works if there's significant more text than 31. Imagine if there's 100 lines, right? We'd still be able to run the same method. Continuing, we can do it with pretty much any data. Here we have some data that's been taken out of Epic. If I create my input here and I use it against medical codes, something interesting occurs. These are labels, medical codes chosen for this transcript. If I submit them now, it'll try to align the medical codes against the transcript input, and the transcript input again is a non-ordered Epic node. So we see that we can identify 4 of the codes. Here I know that this code is actually wrong. What's interesting is that we also cannot find it using the alignment model. The reason why this one is wrong is because it's unspecified abdominal pain. The right medical code for this case is left lower quadrant pain. This is another way of using the alignment model where we can quickly identify that something is missing or not occurring in the text. You could essentially see this as a way of doing quick searches, semantical searches in the text as well. Bear this in mind when communicating about the tool or trying to use it yourself, that it can be used in many creative ways, depending on how we deploy it, either for finding things or for identifying things that is not there. Hopefully this was helpful. And if you have any questions, feel free to shoot them. Thank you.